my most exciting topic because I get to talk about what I've learned really over the last 5 years or so. I started as we started just making robots fly, putting cameras in the air, sensors, extending the internet to the skies above us. And that was, the internet of flying things, if you will. But then over after we got that working, and that took about 5 years, we then started thinking, what was it good for? What were they useful for? What industries could use this sort of reality capture, this kind of, perpetual 360-degree digital twin of what they are? And we ended up getting deeper and deeper into the future of automation and labor. And what I learned surprised me, and we've done a lot of research on labor shortages. And I think what I'm gonna do is just go through some of the interesting statistics on where automation is taking off first and why. So the basic point is this, is that you've heard a lot, and I get it all the time as a guy who runs a robotics company. Everyone says, well, aren't robots gonna take our jobs? Aren't they going to be smarter than us? Singularity, they're going to destroy humanity and all this kind of stuff. And this contrasts totally with my reality, which is that we're not like pushing robots on anybody. We're developing tools, and then they come to us because they have a problem, and the problem typically is a labor shortage. So the headlines that you read are all about replacement, about putting humans out of work, about undermining the nature of the workforce. And yet the reality is that, as you know, this week, all time, like in our lifetime, we've never seen a tighter labor market. We've never seen more jobs waiting to be filled. So what's going on here? And the answer is interesting to dive in. And I'm going to go all through the data. So this is going to be a lot of data. I'll happily share the presentation with you afterwards so you can take it back to your own companies. But to use an example, this is actually our neighborhood garbage truck over time. Different truck, same neighborhood. So once upon a time, it was 3 garbage men. There was a driver, there were 2 guys. They were schlepping around garbage cans. And then over time, the garbage trucks got a little bit more evolved, and it was a driver and 1 guy who stuck the garbage can up against the big old lifty thing in the back. And today, our garbage truck looks like that on the right. There's a driver. It's a 1-man garbage truck. And it'll probably stop there. But that's in a very simple way. The garbage man is the classic job that we think of as being sort of a low-skilled, low-paid, kind of unpleasant job. I don't actually know whether it is or isn't, but it was kind of the cliche example of the kind of labor people didn't want to do. And here it is being replaced by robots. Well, that's kind of interesting, but I know you guys are not in the garbage industry, most of you, so let's move on. How about airline pilots? This is a pretty sexy job. It's white collar, I guess, by some definition, lots of training, et cetera. We are looking at a chronic shortage of airline pilots. We need, according to Boeing's projections, we need 11,000 airline pilots, new airline pilots per year because the workforce is aging, and we're training 3,500 in the United States. It's not getting any better because apparently some guy said the drones were the future. So what do you do about that? Well, once upon a time, there were 3 pilots, then there were 2 pilots. We now have the ability to do 1 pilot. And if you guys, how many people remember the image from the right? There you go. Okay, good. I've got the right crowd here. I'm doing my damnedest to get here. And by the way, the technology is completely there. You do not need pilots in a modern airplane. Why do you have pilots in a modern airplane? It's you, the passengers, who just have not accepted the pure autopilot scenario, and it's Captain Sully's miracle on the Hudson is always what we have to fight on this. But over time, especially for things like freight, like FedEx and UPS and things like that, they're going to start to move to single pilot, a cargo aircraft. They may have fleets. Like a flock of birds where the lead aircraft has a human and the rest of them are platooning. We're starting to see the same thing happening in trucks. And maybe someday over certain locations, it'll be fully autonomous. So if we are going to have human pilots, at least using them on passenger planes, not freight planes. One of the important things, and before I get into the individual sectors, is to remember that it's often, and this is not my research, this is the McKinsey research, it's often the activities that are being replaced by automation rather than entire jobs. And so all of us have a mix of activities that are somewhat drudgery and activities that require the best of our cognitive and emotional skills. And if you think about it in some sense, the things we use today, the emails, word processors, et cetera, are essentially replacing the more drudgery elements of our job, but not our job entirely. They make us better. They're force multipliers. They're kind of an outboard brain, if you will. All of us are smarter because we have a supercomputer in our pocket that knows everything. And so there's that element of automation, and just think about it as like not the entire person, but some element of what they do. Kai-Fu Lee, the formerly ran Google's Google China and some of Microsoft's AI efforts, has got a new book out, and it's really interesting. And the next couple slides are entirely from him. But I like his taxonomy of how he describes about which functions are most easily replaced by AI and robotics. And by the way, I'm using the terms slightly interchangeably. They're both automation. Obviously, robotics involves physical actuation in the world, and AI doesn't. But a lot of robotics has AI in it. And this is the taxonomy he starts with. He says, okay, so this is the normal way that we think about jobs. We have the sort of the creative jobs, and we all sort of sit there on the right side, the symbolic processors and all this kind of stuff, and then the more repetitive ones. And we think of automation being drawn to the left-hand side. But he actually prefers a better taxonomy where you add another dimension of compassion. This is this notion of something that machines don't do very well, which is empathy, EQ, love, if you will. And then if you start to allocate jobs around these two axes, you realize that it's a more interesting way to think about where AI can have an impact. So obviously there's some that are like dishwasher. We have dishwashers, they don't require a lot of compassion, and they're pretty easy to automate. Whereas you have someone like a CIO, for example, which would probably require very hard to automate and requires a lot of compassion. And then you start putting more applications into it, and you get things like elderly companion. It's I'm going to get into the home healthcare in a second, but an elderly companion is a little bit of drudgery of just the washing and the cleaning and the caring, and then a lot of empathy and understanding that person's personal needs. And so when you look at it that way, then it's kind of interesting to look at the replacement cycle. So let's start with the drudgery, the dishwasher kind of thing. That's an easy one for AI to take over. Okay, it wins. Then you move over to the bit here. This is the low compassion, but a lot of creativity. And there you can see AIs and humans working together. In a sense, the supercomputer in your pocket, the outboard brain of Google, et cetera, is a little bit of you and the AI working together. It makes you a better human. Then let's move up to the top left corner, and this is high compassion, but a lot of optimization as well. And there you put like a shell around an AI. So imagine a doctor or a nurse with a diagnostic AI, who the diagnostic AI figures out what's wrong with you and what to do, but the human figures out how to communicate this to you, how to translate it in terms that are most meaningful for you. And then finally, in the last corner, you've got the ones that are, that they require both a lot of creativity and a lot of compassion. And those are the ones that are most the safest domains for humans. And those are the ones where, where really it's just again the supercomputer in your pocket sort of a model where we're going to get better because we have AI rather than be replaced by it. So Kai-Fu Lee's book is just out in the last month, and I very much recommend it. One of the big things he also talks about is the competition between China and the United States in AI. And one of the advantages China has is just a vast amount of data. Because of the Great Firewall of China and the centralization of the Chinese internet, they have the ability to train their AIs at a scale that we can only dream of right now. Okay. So here comes the stats. So according to the Bureau of Labor Statistics, and I just did this research this week, these are the top 5 industries in terms of labor shortages. These are the top 5 industries in terms of open job applications and job positions. And what you can see is not only are the numbers big, and I'm going to go through them, but they're growing. So when you hear about a tight labor market and you hear about labor shortages, it's not everywhere. And these industries are the ones that are the hardest. And by the way, this is not unique to the United States. Any country with, for example, an aging population, what they call a demographic time bomb, like Japan, for example, but many in Europe as well, is going to be having a shortage of healthcare workers. In other words, the ratio of people who need healthcare and those who can provide it is rising. Also, countries that have immigration restrictions, as Japan does, and we sadly are starting to, also are going to end up with a shortage there. Food service, another perfect example, tends to be low paid, not a very satisfying job. And so as people get more opportunities, food service is the one that gets hardest to fill. And you'll know that if you've gone to a fast food place recently. Manufacturing is a little bit of a surprise because you probably have been told that, that manufacturing doesn't happen in the United States anymore. It's all moved to China. All the jobs went away, and there were a lot of manufacturing workers looking for work. That was true in the 70s and the 80s. But what happened is that as automation came in, it leveled the playing field in terms of the labor component of manufacturing. And now there's a lot of manufacturing, in the United States. It's still the #1 manufacturer in the world. And although it's mostly automated, it still needs CNC operators and people who can run the robots, and we have a massive shortage of that. The average age of, I think, a CNC operator today is 55, and they're close to retirement. And we're not training them anymore, and so we're not training enough of them anymore. And so we really have a shortage of people who can operate advanced manufacturing facilities. Trucking and warehousing, obviously the e-commerce boom is causing a drive in that. I'm going to go there. And construction I'm going to talk about at length because that's the one I know best. So let's start with healthcare. Again, aging population, it's best to as people get older, it's best to care for them in their own home rather than putting them in hospitals and facilities. There, of course, it's a distributed job function. More than 1 million unfilled jobs. I thought it'd be interesting to correlate because this is because we have a venture capital perspective on the day. I thought it'd be interesting to correlate the opportunity for technology to satisfy the labor shortages with the amount of investment going into it. So these are the latest statistics, actually, again, from this week. And what you can see is that the funding is rising, but it's still actually not very big compared to the opportunity. Now, I don't think that's because the VCs are missing a trick here. I think it's actually because we haven't really solved the home healthcare technology problem, at least not from an automation perspective. There are a few highlights, however, and one of them I wanted to point out is an autonomous car, a self-driving car company called Voyage. And as you know, self-driving cars are extremely hot market, very fast advancing, but they're highly regulated, and it's extremely difficult for them to get miles and especially operational miles on the street. Well, what Voyage realized is that the perfect test bed for autonomous cars was retirement communities. There's one a massive one in Florida near Orlando. And this is private property. It's entirely, it's extremely, it's very easy to map. It's very well characterized. And now in this community, people can take out their app and just ask for a car to come get them and take them to the store or the gym or their friends, and it arrives without a driver. So we now have the future of autonomous taxis has arrived, but it's arrived interestingly in this private community. And what's great about this, of course, this is exactly what you want, right? As people get older and they get less good at driving, this really limits their freedom and undermines their sense of self. And to give them freedom without creating a safety issue on the street is a perfect application for robotics, which is really what an autonomous car is. By contrast, you may recognize this image from the movie Robot and Frank. The Japanese model was very much to bring humanoid-style robots into the home and have them be like robot nurses. In this movie, you sort of imagined what would happen if the robot empowered the patient to be the disruptive force he wanted to be all along. This is not working. It's not working for a lot of reasons. One of them is humanoid robots are extremely hard. The whole Japanese robotic trend towards bipedal humanoid robot has been a 30-year disaster. There's no, I'll get into this in the end, but in general, robots should be like a Roomba. not like a person. They should be a single purpose, dedicated, they should be optimized for the job rather than our form factor, which is a general purpose, form factor, extremely hard to do what we do. And then on top of that, it turns out that the Japanese experiments at least suggest that the older people are not bonding with their robots the way this movie suggested. So between the technical complexity and the lack of emotional connection, I think that's probably not going to be this future. Okay, let's turn to food service. Once again, nearly 1 million unfilled jobs. Quite a lot of money is going into food. So the VC market does see a lot of opportunity here. Now, it's not all automation. Some of it is just, new concoctions of food or new sorts of retail experiences, blue bottle coffee, things like that. But there is a good bit of automation because of the labor shortages I mentioned before. It's really important to do it. This is something that's just opened up this week. It's called Create, and it's a robot hamburger restaurant. It's kind of interesting to, they're just, you can actually visit it this week. They're open, I think, Mondays and Tuesdays as a trial, as a beta. And the idea here is that, I'll go to the next slide so you can see the details. The idea here is that if you can cut down the labor, you can take that money and invest it into ingredients instead. So you can get really fresh tomatoes and lettuce and bake things on site, et cetera, and then keep them in their fresh state, keep the tomatoes as tomatoes, and only slice them as needed. And so the robots essentially do all the manual work to take fresh ingredients and turn them into hamburgers on an on-demand basis. They expect that right now, there's a bunch of engineers with Apple Watches, monitoring the whole thing. But over time, they expect it could be 1/5 the labor force required, and it's $6 a burger. Whereas gourmet burgers would typically be like $16. So they're trying to do gourmet food at fast food prices by using automation. Early days, but it's really fun. Right now, everyone's going because it's beautiful to watch. All these the pneumatic tubes and the slicers and the little arms moving things around. It's a cool hamburger experience. But over time, it may actually be practical. Now, it's worth noting that McDonald's has a ton of automation, already built in, the fry basket going in, coming out, and all this kind of stuff. But they still also they haven't fully automized the experience, and Creator is an example of doing that. Okay, let's turn to manufacturing. Manufacturing is 500,000 unfilled jobs. A lot of money is going into manufacturing, advanced manufacturing of various sorts. I would not say it's all, basically all manufacturing is automated. I wouldn't say that all the new money going into it is specifically on new automation, but that is generally the trend. It's not only happening in the United States, even in China, where they are also seeing not so much a labor shortage, but an increase in labor costs. China's now finding they're not the low-cost supplier anymore. That's moving now to Southeast Asia. And so, Foxconn and others have done a big national push to automate manual functions for the cost reason, also because for the safety reasons. As you know, there's been controversy about the working conditions of labor, and China's just moving up the value chain. So that's a natural thing to do. For those of you who followed the Tesla factory, it's been a very interesting experience. So the Tesla factory was a model of automation, just all these Fanuc and KUKA robots looks, if any of you have been there, it's just astounding. It's totally Iron Man. You've also probably heard that they ran into some production problems. And Elon Musk has been very interesting in describing that they over-automated. They basically created a brittle system that was very inflexible for changing the model and the performance, and so they ended up dialing it back a little bit because they now recognize that you need both efficiency and flexibility in manufacturing. But still, that's sort of the direction we're going, and that's that sort of human-robot interaction, which turns out to be the sweet spot. Okay, trucking and warehousing, again, is, e-commerce is driving this, big time. Here you'll see a lot of unfilled jobs. The nice thing about the warehousing jobs is that they can move to where the labor is. So it's not like the Silicon Valley hiring programmers problem. But it's also all true that the volume that people have to deal with is just extraordinary. So there's a ton, Amazon bought KUKA, it was a warehouse robots, and there's been a ton of investment going on there. I'm gonna start with trucking. Trucking is a huge shortage of truckers. And right now we're looking at, there's a number of companies who are doing autonomous cars and actually thinking about doing trucks first. Tesla did it, Uber did it. There's a bunch of startups, Peloton, Auto, and others that are doing it. It's probably not going to go to a straight robot truck initially. Some of the companies like Peloton are actually bringing in things like platooning, where you actually have the trucks almost become like a land train, like as a train is on the land, a road train, where they you know how trucks tend to get in these convoys. Well, what the software can do is basically maintain a distance and orientation behind the truck. There's still a driver in both of those, but the stress on the driver is diminished by the fact that the software largely keeps that driver in the right position for all the aerodynamic efficiencies that come with being drafting on a truck behind you. And so those are the kind of the baby steps towards automation, where they're not replacing the driver, but basically replacing some of the more laborious skills of that. And then the warehouse, robotics is just extraordinary. This is out of China. But there's some really interesting statistics about why warehouse, robotics is taking off. It's not just that it lowers the labor cost and it lowers the injuries. Warehousing injuries are, backbreaking stuff. But it turns out that because of, dare I say, the long tail, and the explosion of variety and choice, that the number of SKUs in a warehouse is now exploding. And as a result, the kind of pick and place challenge is becoming beyond what a person with a clipboard can do. And so it's like a hard drive, where we went, back in the Dewey Decimal System, everything was lined up on library shelves, and then we went to random access. And basically, warehouses are now set up like hard drives with random access, where you can have bits anywhere, and the software and the robots will figure it out. And this is essentially what the future of robotics, the future of warehouses look like, where the humans are pushed to the edge. All the kind of picking and moving around of stuff is done by the robots. All the humans will do at the very end is possibly inspect the package, maybe tape it if necessary, but they don't have to walk miles and miles a day just to pick individual items. So let's turn to construction, which is now my field. Construction is so interesting. As you know, it's not only that we have housing shortages, it's not only that infrastructure is due for renewal, but also climate change. And what's going on in Florida right now, what's gone on in South Carolina, what went on in Texas. This climate change leads to storms, which leads to the needs for repairs, et cetera. We are desperately short of construction workers. There are some reasons for that. And these are the ones I really have been spending my last few years knowing the best. The immigration restrictions, the Trump administration's rules on immigration has decimated the construction industry. The workforce is aging, especially skilled workers. It's again average age of 55 for like a bulldoze operator. And it's been very interesting to watch the impact of drugs on the construction industry. The construction industry is the #1 source of workplace injuries. It's backbreaking work. And often those injuries are treated, if you're lucky, they're treated with beer. If you're, more likely, they're treated with painkillers. And so the construction industry became ground zero of the opioid epidemic. And once they got on painkillers, they got hooked on painkillers. Then there's this really interesting problem of the misalignment between drug legalization and workforce drug testing, workplace drug testing. Now in, 30 states in America, cannabis, either medicinal or recreational, is legal. And yet in all those states, you're still drug tested on the workforce. So in other words, you're allowed to smoke pot, but you can't work if you smoke pot, which is crazy. And unlike alcohol, where they only test impairment, with cannabis, they test whether you've used it in the last 30 days. So you're not actually impaired. And what we actually need right here more than anything else is a test for cannabis impairment, rather than use. So we can actually test people on the morning of when they're operating heavy machinery to see if that's an issue. Anyway, that particular those combination of things has basically created the labor shortage we have today. And some of those, like maybe we'll get the drug testing thing sorted out, but some of those things like immigration and workplace injuries are not going away. And by the way, I think that if there weren't for the workplace shortage, we'd have even more construction starts. And so in a sense, the open jobs is artificially low because people aren't even opening jobs right now because they know they're not going to find the workforce. So what do we do about that? Well, construction is the least digitized big industry, even less digitized than farming. And it's if you go to a construction site, it's pen and paper and printed out blueprints, and the workers have flip phones, and there's hardly digital to be seen, and there's a huge opportunity there. This is one particular example where they just use the robots to frame unusual prefab structures and walls and things like that. But there's tons of others. You may have heard of Katerra, which is considered the unicorn of construction. What Katerra is doing is essentially designing buildings, large buildings, housing projects, and housing structures and others to be prefabbed, and then doing the prefab themselves. So rather than taking a random design and then seeing if you can prefab elements, you design the building to be prefabbed. I didn't put a slide on this, but one of the most interesting companies in this space is WeWork. You may not think of WeWork as a construction company. You may think of it as a co-working space. But you may wonder why SoftBank is putting another, I don't know, what is it, 20 billion or something like that into it. SoftBank's not stupid. WeWork is the most interesting company nobody understands. What WeWork is doing is they are renovating 6,000 to 10,000 office, floors or spaces or offices per year. Sometimes for WeWork and sometimes for other companies. They sort of flow the WeWork experience or the Google experience or the SAP experience or whoever they want. They flow that experience into existing space. They do renovation at industrial scale. And the way they do it is by automating. They just empty out the room. They, the floor, whatever, they reality capture it with a laser scanner. Then they use their software, which sort of understands what a WeWork experience is or an SAP experience in terms of like the size of the rooms, the ratio of conference rooms to offices, to telephone rooms, to public spaces, the aesthetics of the whole thing, acoustics and all that. They have software that kind of flows that experience into that space. Then they have another bit of software that then optimizes that experience for the materials, the glass and the metals and the bits that are expensive. Then they prefab all those materials in factories one's in New Jersey, but there'll be more. And then it's essentially trucked to the site and then assembled by low-cost workers like Lego. So we have not seen anything like that since the boom days of retail. So the Starbucks used to have operations that could turn any random location to a Starbucks. The Gaps could turn any random location to a Gap. The hotels had a little bit of that in terms of the Marriotts of the world and turning sort of new buildings into an efficient prefabbed Marriott experience. But this is now happening with modern tools at an extraordinary scale. And it's all because they're automating every one of these elements and taking the human element down to the bare minimum. So Katerra, WeWork, and a bunch of the other prefab companies are a good example of that. Drywall sanding is something you probably never think about unless you've done it. Whenever there is a disease named after your profession, it's probably a bad profession. Silicosis, it's a bad thing. Drywall sanding is dusty, it's horrible, it is back-breaking work. It actually closes the site for days because it's so dusty. It turns out that a robot arm does this beautifully well. So there's a company still in stealth, but coming out soon called Canvas. And they basically replaced the human with a robot arm that does the drywall sanding. It's actually not a hard technical problem. The hard problem is selling it. And so rather than selling it as a robot drywall sanders, they just bid for drywall sanding contracts. They don't tell anybody, if someone else is doing, I don't know, $100 a wall, they'll do $80 a wall. And then what shows up is not an army of dudes, with masks, but one guy, a robot handler and a robot. And it's better, it's faster, it's more efficient, it's safer. And so they basically turned it into robotics as a service. And that's a cool thing about whenever you can turn robots into something that doesn't look like robots, or at least doesn't scare people like robots, then it's much easier to sell. Another terrible job is drilling holes in concrete. Again, perfect application for a robot arm. Just imagine what's the back-breaking work of sitting on a ladder doing that. Has to be done. Robots do it great. Again, they sell it as a service. My company focuses on the survey side, the quality control side, all the bits of sort of when you're sort of like the Internet of Things, the sensor side. So one of the problems with construction is that typically you design it, an architect will design it, a general contractor, a civil engineering firm maybe will do the plan, then a general contractor will build it. And basically, the moment you dug your first spade of dirt, it's not digital anymore. It's an analog process, and all you have is some general contractor's daily report where they write things down. They say, yep, we did that or we didn't do that. And as a result, the average project is 80% over budget. An average large commercial project is more than a year over schedule because stuff happened. And the reason, you can only manage what you can measure. And so it's really hard to measure progress on a construction site, not accurately. And there's a lot of incentives to lie or be economical with the truth. Because often these contractors are paid on a cost-plus basis. Sometimes they're paid for their time. And it's always the costs all get passed on to the client who doesn't have any transparency and visibility into what's actually going on. We now have the ability, with the Internet of Flying Things, and indoor scanning as well, to basically get what's called a digital twin. We do reality capture on a massive scale. It's completely automated. These drones just circle the sites every day. The rovers scan the sites indoors every day. It is like, right now, for regulatory purposes, there has to be human present. They don't actually do anything. They just turn on the red button. And so this is like, the construction side of the future is where the guy comes in the morning at whatever, 6:30, 7, opens up the gate, opens up the trailer, turns on the generator, and presses the drone button. And then in that daily scan, and now you have a digital twin that's up to date and living. And now you actually know progress. Now you can actually measure the volume so you're not being cheated on materials and things like that. I mean, it's all got really easy. And what we're doing is we're not so much replacing the surveyors and the quality control people and the layout artists. We're actually doing something that they're not doing. Because they're expensive, the humans, when they do this, are expensive, it wasn't done very often. It was done at like the beginning of the project and the end of the project. And so what we're doing is by making reality capture, free, it becomes possible to do it more often. And so now it's happening every day, and now suddenly the promise of a digital twin is real because it's a living model that's up to date because the cost of measurement became zero. We're doing the same thing on airports, there's 30,000 airports in America. They all have to be surveyed every year for cracks and things like that. It is you ever wonder why sometimes your flight's delayed because, hey, they closed a runway? Well, they close a runway because there's some guy out there with a camera taking pictures of cracks. Incredibly disruptive to the national infrastructure. And so we're like, well, that doesn't, we can do that. And so what we do is now in 15 minutes, they close the airport, they close the runway for 15 minutes, the drone just flies up and back. Then we use computer vision and AI to detect the cracks, and highlight the ones that need to be done. And then if in fact any repair work needs to be done, they just go immediately, they'll go directly to where the crack is. They already have the materials ready. They're already prepared. And we're reducing the downtime of airports from days to hours, to say nothing of the labor cost of doing that. Perfect example of automating something, and everybody wants this. Even the contractors, want this because if they don't have to walk up and down airports all the time inspecting them, by hand, there's other elements of the airport infrastructure they could be inspecting. There's better ways. There's a shortage of surveyors as well, so they don't feel threatened by this at all. So finally, I wanted to end on one last note, which is kind of a pet peeve of mine, and then we'll take questions afterwards. So I've been talking a lot about robots, and I have to admit that I have a very mixed feeling about this word. As a matter of fact, my company name, although officially 3D Robotics, we haven't used the word robotics for years. It's 3DR. If you ask me what the R is, I might say reality capture, or I'll make up something, but we don't like the word robot. And the reason we don't like the word robot is because we realized that we got away with murder in the early days. People think that robots are cool. People think that drones are cool. People think that flying robots are cool. But the people who think that robots are cool are not our customers. The people who have a problem, who want a job done and are agnostic about the shiny technology are our customers. And we got seduced by the nerds, the early adopters, who like robots, and we realized that ultimately we have to sell the CIO, we have to sell the CFO, we have to sell the CEO, and they don't buy shiny, they buy ROI. So what we realized is that the lessons the Japanese learned just this last week. Rethink Robotics. Rodney Brooks is a genius, a giant in our field. His company, Rethink Robotics, went bust. $150 million hole in the ground, and there were many lessons behind this one, but one of them is they tried to be human. It had a face. And turns out nobody wanted a face. They wanted to be a cooperative robot that works with humans, and they didn't work with humans by being emotionally affecting. And as I showed you in the Kai-Fu Lee slide, it turns out that robots just are not good at that, and people don't react well to that. Instead, they got beaten by Universal Robotics, which has an arm, just a regular arm. It's a good arm. It's a very effective arm. It's a very precise arm. It's easy to use. It doesn't have a face. And I think there's a lesson in that which actually goes back all the way to my own personal history. This is my grandfather, Fred Hauser. Fred Hauser was a Swiss immigrant to the United States in the 1930s, moved to LA to work in the movie industry, worked for MGM to bring about the talkies. He he's a Swiss engineer. He's pretty good at gears and mechanical stuff, and so they put tape loops. They put audio tape onto film. But at that same time, and if you've seen the movie Chinatown, at the same time, Los Angeles was greening the desert. They were controlling water, and all of a sudden, everybody was building. It was one of these lawns, and all these lawns had to be watered, and everyone was sitting out there watering their lawns every day. And he thought to himself, as a Swiss engineer, what if I put a clock on a sprinkler? Then it'd be an automatic sprinkler system. And so he invented the automatic sprinkler system. So if you have one, you have my grandfather's patent there to thank for that. My very, very tiny family fortune came from that until it expired. And I spent my summers with my grandfather in his workshop working on automatic sprinklers. And my take-home lesson from that, by the way, I forgot about it for decades until I got back into engineering and invention. And then I realized that what we don't want to turn robots into shinier robots. We don't want to talk about robots. What we want is basically sprinklers. Sprinklers are robots that just do their job. You just stick them out there in your garden and you forget about them, and they just do their job. Like a dishwasher, like a washing machine, they just do their job. They are essentially invisible. And if we do our job right, we're not going to be talking about robots. The same way we don't talk about electricity. It's just there. It just works. Automation was so seamlessly integrated into our needs in our workplace that we take it for granted. And this is the way they promoted the sprinkler. They didn't promote it as the lawn and the sprinkler. They promoted it as freedom to go to the beach. And that, I think, is really the lesson. If automation wins, it's going to be because we feel liberated, we feel empowered, not threatened. We're going to welcome automation into our lives because it's going to make us better humans. And with that, thank you very much, and I'll take questions. Yes, sir.
We're in the construction industry, and we're actually a contractor over $1 billion. So we're in the construction industry, contractor, probably have the most boots on the ground in the Western U.S., so your talk echoes with us. Just Monday, we had a roundtable with our executive group just talking about we can't get enough people and looking at technology, what do we do? We're basically maxed out as a workforce and as a real problem. And I think the challenge is how do you attach technology to that solution? Those decisions are made on shareholder value and not shiny objects. And so how do you make that path and journey? I struggle as a CIO to really articulate that well and get that explained. We're in an old kind of industrial mindset of a company, and how do you change that mindset to this new information? And I find it extremely challenging, and I hope you make house calls.
Absolutely. I mean, so you are preaching to the choir on that one. I spent the last 5 years, coming up with better but not perfect answers to that. I mean, obviously, you focus on ROI. You just explain how $1 invested in this technology is going to be $10 in savings or in increased profit. So that's one. Okay, that's easy to say, but how does it actually work? Then you break it down into, so like some of our customers are finding that the savings come from risk reduction. So for example, you could probably know better than me, but what percentage of construction projects end in a lawsuit? Some sort of dispute between contractor, subcontractor, client, whatever. 50%?
Yeah, they still come back in the 40s when they see your name as an asbestos problem, so it's constant.
Exactly. So lawsuits are a big thing, and what we find with there's one way to solve. Well, there's two ways to solve a lawsuit. One is to fight it out, grind it out in the courts at expensive costs, and the other is to bring data, bring evidence. And what we're finding is if you know you're in the right, and you just need evidence, this constant monitoring the site gives you a paper trail. And we found our customers basically show up with a scan that shows that the complainant is lying, and boom, case settled. So that's one little element. Another element is increasingly we're finding that construction companies have been able to kind of pass along costs for some time. Not a bad thing. It's a cost plus model. It's very, very normal. But increasingly, clients are becoming more sophisticated about what are they paying for. And in certain governments, Japan and the UK in particular, they're requiring BIM, Building Information Modeling, as a form of transparency into what's actually going on. And I think that right now, large vertically or integrated companies, probably such as your own, see internal efficiencies. You have enough transparency into internal costs that you can actually see what the advantage would be. The governments are trying to impose that same sort of transparency onto their contractors by requiring BIM. And so I think you may find that some clients are just starting to ask for it. And then the last thing we're noticing is that it's a good example of fraud reduction. This almost certainly doesn't happen in your company, but in many parts of the industry, the inability to measure volumes and measure materials accurately leads to some opportunities for fraud. So like there's a hole. It's like, and the GC says that is a 10 cubic yard hole. And now he knows it's an 8 cubic yard hole, but he calls it a 10 cubic yard hole. He then orders 10 cubic yards of sand, let's say from the sand dude, and he's like, hey, I need 10 cubic yards. The guy delivers 8 cubic yards, the hole is filled, and they share the extra 2 cubic yards of, obviously that's not a lot of money, but that's where a lot of the fraud happens, is the inability to accurately track those things. And so maybe just from a pure kind of risk reduction, fraud reduction perspective, you get some ROI. And then there's some customers just actually like knowing that you're the higher tech operator and that you give more transparency. And so some clients may want that. I mean, I'd love to talk to you more about this. This is like my favorite topic. Any other questions? Yes.
I'll repeat the question maybe. White-collar jobs that you think are going to be disrupted, potentially in a beneficial way, but potentially in a negative way as well.
Yeah. Well, obviously, that's been going on since the end of the typing pool and the end of the telephone operator, et cetera. One of the interesting questions is what happened to the typing pool? Where do they go? You watch Mad Men in the 50s, there was a typing pool. Did they retire? Did they go on to other things? And it turns out that it's a range. Some of them went on to be executive assistants. Some of them went on to be accountants and financial analysts and kind of moved up that. Some of them did, in fact, retire and leave the profession. Right now, there's a lot of interest in AI replacing certain analytical functions. I think we're right at the point where AI has gone from extremely exciting to almost every time you see AI, it's BS. It's just a flat out lie because we all do it. Everybody wants to see AI in the presentation. We all put AI in the presentation. And I can tell you, when I put AI in my presentation, yeah, we got AI. We don't use it because we don't have enough data to actually train it. We actually use computer vision and general statistics, but it's building up the data set that will lead to AI. So I think that it's early days to actually think of AI as being replacing high-level human functions. Instead, it's just essentially it's like business intelligence or any other kind of automated thing. Salesforce has probably been thinking, Salesforce automation is what CRM is. They've been thinking probably hardest about this. And what's interesting about it is that every bit of automation they bring is designed to empower the salespeople rather than replace them. So the idea in those particular examples is not that salespeople aren't required. It's that they're wasting their time. It's that every minute is precious. And if you can just use those minutes best, they're happier, better results, et cetera. So we're not seeing it at this stage, and even especially in programming, which is the world that I'm in as well, we have not really found any kind of successful software programming automation. What we have found is tools that make our programmers more efficient. So I think we may have gone from the era of replacement to enhancement with technology right now. Any other questions? We're just at the top of the hour, so one more, yeah?
So for what your organization's doing, do you see yourself selling more to the owner, the engineer, architect, or the construction company?
Yeah, that's a great question. It's a very fragmented business. And it's all based. So it often it's just this supply chain of owners, general contractors, subcontractors, surveyors, insurers, things like that. We find ourselves mostly selling to large vertically integrated general contractors, probably like the gentleman who spoke before. The reason we're selling to them is because it works best when they actually own the materials. And these are basically companies that are already doing their own. They're large enough to do their own surveying, their own quality control, their own reality capture. So if they're large enough to do it themselves, then they're large enough to integrate it well and to see the efficiencies. If they're a subcontractor and they're not, so those are the best customers. If they're a subcontractor, i.e. just a surveyor, then some of them might find it actually kind of threatening, to their role, so they wouldn't adopt it. Others would do it, but then they'd have to integrate the data into the general contractor's data pipeline. And we make that as easy as possible. We're kind of deeply integrated into the Autodesk. Autodesk is one of our investors, so we're deeply integrated into the Autodesk pipeline. But that's a little less neat. So right now, it's, as you would expect, the larger vertically integrated ones are the ones who are most coherent and thoughtful about integrating new technologies, and everything else is kind of ad hoc and spotty and requires us to do a lot of work on integrating incompatible systems. Yes, up here.
Thank you. Given the state of the country's national infrastructure, what role do you think city, state, and national governments should play in having technology improve safety, returns, deliver on budget, on time, things like that?
Yeah, that's a huge opportunity. That's probably where we're focused most right now, infrastructure. So the answer is that we're way behind on our infrastructure maintenance, improvement, et cetera. We're now realizing that, what with things like climate change, like for example, the U.S. Army Corps of Engineers is one of our biggest customers. They do dams, levees, dikes, waterways. They're, when you have a forest fire, when you have a hurricane, et cetera, they're the first port of call. And, right now we're realizing that a lot of our water infrastructure, for example, is fragile. I wasn't anticipating the sort of climate, conditions we're going to be dealing with right now. And so they just don't have the resources to go out and manually survey all this. Department of Interior, Bureau of Land Management, U.S. Geological Service, Fish and Wildlife, they're all our customers because they all realize that they have this obligation to characterize and maintain and preserve our national infrastructure, but they don't have the tools to do it at scale. They don't have the resources, et cetera. So, bridge inspection, that actually involves like hanging a dude on a rope under a bridge. That's crazy. We obviously do that with drones. Cell tower inspection, electric infrastructure, pipeline infrastructure, hydrology, ecology, all these things we've just been sort of guessing at. We've been kind of getting away with very, very occasional measurements. A lot of the databases go back to the actual construction, which may have happened in the 60s and haven't been updated since then. So before we can improve and expand our national infrastructure, we actually have to understand it. And so there's this national effort to characterize everything, just see where are we, where should we focus our resources. The airports being another example. So that is probably going to be our biggest market going forward, because it's such a pressing need and so poorly served by the manual methods. Do we have time for one more, or should we put you back on schedule? Where are my bosses out there? That's the one more question? Yes, we'll take one more question. Don't make me look bad here. Yes, sir.
So is there anything you're doing with sort of the city inspection side of this, which often causes delays, rework? I mean, if you could inspect something as the work is going on and that be approved by the city, it would cut a whole bunch of time out.
Totally. The answer is not as much as we would like. We do a lot of road inspection, but not in cities. We do a lot of building inspection during the construction. But the problem with city inspection, and this has to do with with the unique qualities of drones, is that we're not allowed to fly over people. We're not allowed to, there's lots of restrictions, privacy, safety, and things like that, but we're not allowed to fly. We can only really fly over cleared areas. So although we did the new Uber headquarters, which is going up just a few blocks from here, we had to stay within the boundaries of that construction site. It's going to take a while before the FAA gives us permission to fly over people. There's going to be all sorts of safety things we need to put in. Plus, I think there's a public perception issue. So right now, police and fire do have permission to fly drones over people in the case of emergency, but we don't yet have, let's say, community permission to fly drones over city streets for safety and also sort of public perception reasons. So in the absence of that, we do ground scanning. So we do a ton of inspection for a highway, if they're building a new highway or a bridge or something like that, where we can clear the space. That's done. We do that all the time. But what you're describing is kind of the urban mapping. That's actually being done on the ground with things like autonomous cars and Google Street View, and indoors is being done with our ground rovers. But I think we're probably 3 or 4 years away from a regulatory regime that would allow this. It's probably going to be aligned a little bit with the air taxi, the sort of what they call urban air mobility market. And so once air taxis are allowed, it'll be much easier to have aerial surveillance. Well, surveillance sounds a little scary, but aerial scanning, inspection, characterization allowed as well. Then the sky will be dark with drones, as we've always wanted. All right, great. Thank you very much.